Our next presenter is Robert Gustas from British Columbia. He's going to talk about using shell middens to explore Indigenous population change in British Columbia. All right, Robert. There he is. The floor is yours for the next 25 minutes or so.
Great, thank you so much. And thanks to Liam for that amazing introduction to the use of GIS and geomatics in archaeology. So once again, my name is Robert Gustas. I'm a grad student at the University of Victoria, working with doctors Ian McKechnie and Quinton Mackey. And today I'm excited to share some very preliminary results from my dissertation work, which is trying to use shell middens to explore Indigenous population change in coastal British Columbia, specifically the west coast of Vancouver Island. So the primary research question, which I'm trying to tackle, is what was the degree of population change in Barkly Sound, British Columbia between the pre and post-contact periods? Specifically, how can archaeological spatial data be used to create estimates of shell midden volume? So specifically, how can we take legacy data sets, which archaeologists have been collecting for almost 50 years now in this area, and use that to estimate the volume of sediments which have been deposited by people over the last 5,000 years in this area? Can we take those estimates of archaeological sediments and convert them into measures of the biomass of fish resources that they contain? Can we use these shell middens as a proxy for population size based on the principle that there should be a relationship between the number of people at a site and the amount of stuff that they're depositing? And what was the degree of population change between the pre and post-contact periods? For those of you that are unfamiliar with them, shell middens are accumulations or mounds of shell-rich sediments created through human deposition events. When we're actually excavating them, if you look at the top two pictures here, this is what these sediments look like as you're digging them up. You can see that all the kind of white flaky material in them is actually shell and bone. It's been deposited by people. And if you look at the bottom image, that kind of first rise that you see at the bottom of the image is the accumulation of a shell midden. So that's what it looks like on the landscape. And these are complex long-term records of human activity. In some cases, in this area, recording the daily activity of 5,000 years of human occupation. Most existing research has focused on their extent and depth, with less attention being spent on their 3D shape and volume, which is kind of the area that I'm hoping to explore. So my study takes place in Barkly Sound, which is an approximately 12 by 8 kilometer size marine embayment on the west coast of Vancouver Island, close to the contemporary communities of Ucluelet and Bamfield. Specifically, I'm looking at everything that falls inside this red square. And it's important to note that this area is home to large portions of Pacific Rim National Park Reserve, and this has significant archaeological implications because of the thorough baseline surveying that was done during the creation of the park. This area is also home to at least 175 shell midden sites. This is by no means a complete list of these sites, as there are large portions of this area which have not been surveyed by archaeologists. So this is the available data that we have to work with. And looking at this area from the air, you can see that it is kind of the classic West Coast temperate rainforest, rocky intertidal, absolutely gorgeous area, and just really a marine-driven and marine-focused environment. It's incredibly important to recognize that this work falls on the traditional territories of the Ucluelet, Toquat, Chushat, and Koyat First Nations. And it's important to think about this landscape in the larger Nacholneth worldview, Nacholneth being the larger language family that all of these First Nations fall under. And if we look at these early historical depictions, the top two gathered by John Weber in 1778, we can see that in the top left image, there are fish drying from the ceiling racks. There's a whalefin effigy in the back corner. If we look at the image on the right, we can see one of these plank houses, and it's located on top of a mound of sediment, most likely a shell midden, depicting the size and scale of these features. The deepest shell midden in our study area is over 7 meters deep. If we look at the image on the bottom, a little bit more recently, we can see just how important marine transportation technologies, particularly canoes, were in this context. And all of this just illustrates the importance of marine resources to these peoples. We're lucky enough that Barkley Sound has a long history of ethnographic research, beginning in the 1800s with George Blenkinsop, carried on in the early 1900s by Edward Sapir and Philip Drucker, and then most recently, Denise St. Clair has been working on ethnographic and archaeological projects in this area for over 50 years. On the archaeological side of things, there's an equally long history of research. The first formal excavations were conducted here in 1968 at Aguilar Point. There was a large-scale survey of sites between Port Alberni and Barkley Sound in 1975. The Pacific Rim Archaeology Project completely surveyed the areas falling inside the park between 1982 and 1984. The Ohio Ethnoarchaeology Project explored and excavated the largest site in the Broken Group Islands, Hawaii, in 1984 as well. The Tokwa Archaeology Project surveyed sites on the north coast of the embayment between 1991 and 1996. The Tashat Archaeology Project looked at the two largest sites on the islands between 1999 and 2001. And over the last 20 years, there's been a scattering of smaller projects also looking at equally important sites. And all in all, this gives us an incredibly rich archaeological history to pull from while doing this research. The first Europeans to arrive in Barkley Sound arrived in 1787. That was William Barkley and his ship, the Imperial Eagle. They were followed shortly by Jose Maria Narvaez in 1791. And it's Narvaez who provides our first population estimate. And he states that he believes that Barkley Sound contains more than 8,500 people. The first formal census is conducted in 1790, and for the entire Cholneth group, so basically the peoples living on the west coast of Vancouver Island, that population is estimated at just over 25,000 people. By the 1840s, this population has decreased to just over 7,000 people, just over 3,000 people in 1888, and reaches nadir in 1924 with a population just under 1,500. However, over the last century, that population has dramatically increased. The 2016 census recorded 4,300 individuals. However, this is a disputed number, and it may be as high as 10,000. And this population decrease is largely due to, among other factors, multiple waves of smallpox, tuberculosis, and other diseases introduced during European contact. The exact effect and scale and scope of these changes is poorly resolved, but we do know that they had significant lasting effects on these populations. If we look at just the 1862 smallpox epidemic, one of 20 different epidemic events recorded in British Columbia, we can see that communities across British Columbia suffered tremendous population loss, anywhere from 20 to 70% of populations. So that's just a really sobering number. So if we accept, which I believe this to be a low number, that there were 8,500 people living in Barkley Sound, we can kind of guess where they would be located based on the relative size of sites within Barkley Sound. So if we take those people and allocate them to sites based on the size of sites as a percentage of the total area of sites, we can kind of see that peoples tend to cluster on the islands and the north and south ends of the embayment, which makes sense if you look at the traditional historic era breakdowns of communities and groupings. So in doing my research, I'm going to pull from two commonly utilized methods of population estimation. The first of these are living space estimates, which determine the amount of space required by a person. The kind of constant that most archaeologists refer to as Narrow's constant, which is 10 meters squared per person. This is a number which has been highly critiqued. Other people have tried to look at roofed space, storage space, living space, site area, catchment area, basically trying to figure out how much space does one person require, and then estimating population based on the size of your archaeological sites. I'm also going to make use of accumulation rate studies, which use artifact use life, discard rate, and recovery rate to estimate population. Basically, you're looking at how many of a class of artifact you're finding, and trying to figure out based on how quickly those items would be replaced by the population using them, how many people were inhabiting a site. And it's based on this mathematical equation here. And we are not the first to apply it to faunal remains, but I think we're the first to do so with the intention of combining site volume with that. So the methodology that we're employing here is we're trying to use shell middens as a proxy of past population size. And the way that we do that is by determining the volume of the midden. So how much sediments do we have? Then trying to determine the amount of biomass, in this case, fish remains, that those sediments contain, converting those fish into the amount of food energy or calories they would provide, and then figuring out how many people could be supported from those calories. We also take a time averaged approach in which I'm not super concerned with what the population was at any given point in time, and we're kind of focusing on comparing the aggregate pre-contact population to the post-contact population. And then, unlike many previous attempts at archaeological population estimation, this technique is actually grounded in the material culture, the actual physical items that we're finding on the ground. So to guide our work, we're lucky enough to have high resolution LiDAR and trim data for our study area. This LiDAR is of sufficiently high resolution that we can actually depict many shell middens from the data. We also have orthophoto and satellite imagery that we can make use of. And again, of sufficient resolution that we can depict things of archaeological significance. And then luckily, for the vast majority of sites that have been recorded in this area, we have incredibly internally consistent, accurate site maps like the one that you see here. And these maps are so accurate that we can actually fit them to the landforms that we're seeing in our LiDAR imagery, and then digitize them to gather the extents, the area of these sites. And because you can see here, they're not perfect. If you look at the right-hand side of this polygon, you'll notice it's a little bit out of place. So every once in a while, we do have to do a little bit of manual adjustment to move things where they're supposed to be. Due to the long history of archaeological excavation here, we also have the ages of many of these sites generated through radiocarbon dating, as well as the depth of these middens, which have been soil cored to gather those dates. So this effectively gives us the length, width, and depth of these middens, which will become important later on. And then my supervisor spent his dissertation looking at the faunal composition, or the animal remains found in these sites, and using that to estimate the minimum number of fish that were in his samples, or in other words, the density of fish per unit of volume for these sites. So our approach to estimating midden volume is to go with a general model of midden volume, as opposed to a site-specific model that might be generated from LiDAR or photogrammetry. And the reason we've gone with a general model is it's more easily scalable to large areas, the 175 middens that we're hoping to analyze. And we can make use of commonly collected legacy data sets that map to those sites. Additionally, the acquisition of photogrammetry and LiDAR and other things like that on the Northwest coast are pretty difficult due to cost and the incredibly dense forest cover in these areas. So in terms of picking a geometric solid for our general model, we were guided by the observation that middens thin as they approach their edges, and they tend to infill concave landforms. So we also wanted to pick a shape that could be defined by the length, width, and depth of the midden. So that left us with going with an ellipsoid, more specifically a semi-triaxial ellipsoid. And an ellipsoid is simply defined as a three-dimensional figure whose plane sections are ellipses or circles. It's defined by this mathematical formula here, which we use to lay a point grid at a 1 meter interval across our midden boundary. We then use a bounding rectangle and an ellipsis fitted to the inside of that bounding rectangle, which you see in green and red here, to solve for the height of the semi-ellipsoid for each of those points under that shape. Because we're working on a 1 meter by 1 meter grid, we can then take the height of each of those points and sum them together to get the total volume of the shape. And while I don't go into those details here, we've actually done our best to validate the accuracy of this method and those estimates using other data sources. So in 3 dimensions, the means in our middens look something like this. So that's the first stage of our analysis, is determining the volume of those sites. If we apply it to a specific site, our case study is going to be DFSH 31, also known as Lower Dice Box, on the outer edge of Barkley Sound. We estimate the volume of this site at just over 4 million liters. We know that it was occupied, based on radiocarbon dating, for about 800 years. My supervisor sampled and analyzed 61 liters of sediment from this site, and in that process estimated that 61 liters contained about 305 fish. So if we take the density of that fish, which is about 4 fish per liter, and apply it across our entire estimated volume of that midden, we get a total count of just under 20,000 fish. And here you can see the breakdown by count and percentage for each of those categories. If we look at one of those species, my supervisor's favorite species is herring, so I always use it in all of my examples. We can see that on average, a herring weighs about 121 grams. We know that 100 grams of herring meat produces about 270 kilocalories. We estimate that there are just over 5 million of them. We know the site has been occupied for 800 years. And that allows us to calculate that on a per year basis, so for each of those 800 years, herring were providing just over 2 million kilocalories worth of energy. Now, if we accept that humans on average require about 2,700 kilocalories, this is a high number, we can then estimate that herring were providing enough food every day for 800 years to support 2.15 people. And if we take this same process and we apply it to all of our other species of fish, we can see that this site is providing about 29.26 person days worth of food every day for 800 years, with the primary contributors being salmon, rockfish, herring, and halibut. So that gives us a total energy of lots and lots of kilocalories. And if we convert that into a slightly more understandable unit, we can see that this is the equivalent to about 39,000 Big Mac hamburgers in total, or annually just under 50,000, with 135 hamburgers worth of calories being consumed at this site just from fish every day. In terms of weight, this is just over 17 million kilograms, or 17,000 tons. This number to record and document an even larger population. So in conclusion, measures of shape and volume can be calculated for shell middens using this general model. Minimum estimates of fish biomass contained within these middens can be determined. We can use that biomass to determine the amount of caloric energy that would have been available from these resources, and use that to determine the population that could have been supported, and place that in the context of the historic population estimates. Future work here is to calculate biomass for more middens in Barkley Sound. I actually didn't have time to update this presentation, but we've done the same process for actually 4 more sites in Barkley Sound. We're hoping to scale it up to the total of 178 middens that we've identified. We need to create more targeted estimates of caloric requirements, because 2,700 is a high number. It's not going to be reflective of your entire population. That's the number that is frequently cited by the US Department of Agriculture for an active 18-year-old. And then lastly, we need to convert our live weights of fish into the proportion of the fish that's actually edible, and adjust our caloric yield based on that. So none of this project would have been possible without the support of the Hackeye Institute, who helped us acquire our LiDAR and orthoimagery, my home department, the University of Victoria, Parks Canada, and the Tayshat First Nation, who we have a long-term collaborative agreement with, and Shirk, who has funded my PhD. Thank you so much for your time. I'd be happy to take any questions you have.
Hi, Robert. Thank you so much for your presentation. It was really interesting. We still have a few minutes, and we'll wait for the questions to come in. Myself, I really like the calculations to see how many fish was able to feed it, how many people, for how long. That was really cool. Roger Wheat said, wonderful application of LiDAR. Absolutely. Absolutely.
We did get a question in the chat from Karen G. Are there implications of climate change, rising sea levels in your research? For example, in the slide/map where the Midden appeared out of place, perhaps it is correct and now flooded?
So yeah, so thankfully over the time period that we're looking at, kind of the last 2,000 to 3,000 years, the sea levels have been remarkably consistent. But if you go back far enough, 10,000 years, you see a very different landscape. Sea levels were significantly lower than they were today. But we don't believe that to be a huge factor influencing the placement of middens at the time period that we're looking at.
Okay, so if anybody has any questions, you're welcome to leave them in the chat, and I think Robert can answer them. William asks, fantastic presentation, Robert. Was this all done manually? Are there potential machine learning applications to this research?
I'll start with the first part of your question, Liam, which is that I digitized the midden boundaries by hand and collected their depth measurements from all kinds of sources by hand. But once that's done, the volume calculations are done with a Python script. So you just plug in your feature class and let it run. And then the biomass calculations are all done in an Excel spreadsheet. Not too much by hand once you get the process worked out. And then in terms of machine learning, I guess the application there would be the ever-going quest to try and use AI to do feature detection on landscapes to detect middens would be one application place I could see applying that. But the biomass and population side of things are pretty much just straight arithmetic once you get your numbers dialed in. Actually, one of the aspects of this project that proved to be more challenging than I ever anticipated was trying to figure out just how much does a salmon weigh, because there's huge variation in fish size based on how old the fish are, where they live, what time period they're from. So it's working with a colleague at UVic, Dylan Hillis, we had to go through tons and tons of data to create distributions of fish size for different species and then pull statistics from those distributions. There's been the aspatial side of things have been just as challenging as the spatial side for this project.
Byron also asked, has there been research on how to estimate contributions to caloric intake from other types of food sources for these populations?
That's a great question. And we're focusing on shellfish just for the sake of simplicity at this stage, because like many graduate students, I started with an idea that was this big and had to realize that taking out something this big was more doable in the time frame. But I'm forgetting the name of what it is, but a American sailor was shipwrecked and lived with the Nishonath groups of Nootka Sound, which is immediately to the north of our study area in the early 1800s. And he kept a journal in which he recorded almost everything that he ate for a year and a half while living with them. And we see from his notes, and this is supported by the archaeological remains that we find in these sites, that the primary food sources are fish and shellfish, with a much smaller factor being contributed from birds, and almost no terrestrial fauna is present in the archaeological remains of these sites. So also marine mammal is the other element that's hugely contributed to these sites. But there are technical difficulties that make estimating the amount of marine mammals that are present really, really difficult. Again, kind of why we've chosen to focus on fish for this stage of the project.